Mastering, a form of audio post-production, is the process of preparing and transferring recorded audio from a source containing the final mix to a data storage device. The source from which all copies will be produced. Recently digital masters have become usual, although analog masters, such as audio tapes, are still being used by the manufacturing industry, notably by a few engineers who have chosen to specialize in analog mastering. Mastering requires critical listening. However, software tools exist to facilitate the process. Mastering is a crucial gateway between production and consumption and, as such, it involves technical knowledge as well as specific aesthetics. Results still depend upon the accuracy of speaker monitors and the listening environment. Mastering engineers may also need to apply corrective equalization and dynamic compression in order to optimize sound translation on all playback systems. It is standard practice to make a copy of a master recording, known as a safety copy, in case the master is lost, damaged or stolen. History: pre-1940s, in the earliest days of the recording industry, all phases of the recording and mastering process were entirely achieved by mechanical processes. Performers sang and/or played into a large acoustic horn, and the master recording was created by the direct transfer of acoustic energy from the diaphragm of the recording horn to the mastering lathe, typically located in an adjoining room. The cutting head, driven by the energy transferred from the horn, inscribed a modulated groove into the surface of a rotating cylinder or disc. These masters were usually made from either a soft metal alloy or from wax. This gave rise to the colloquial term waxing, referring to the cutting of a record. After the introduction of the microphone and electronic amplification in the mid-1920s, the mastering process became electromechanical, and electrically driven mastering lathes came into use for cutting master discs. Until the introduction of tape recording, master recordings were almost always cut direct to disc. Only a small minority of recordings were mastered using previously recorded material sourced from other discs. Advances: the recording industry was revolutionized by the introduction of magnetic tape in the late 1940s. Magnetic tape was invented for recording sound by Fritz Pflumer in 1928 in Germany, based on the invention of magnetic wire recording by Waldemar Poulsen in 1898. Not until the end of WW2 could the technology be found outside of Europe. The introduction of magnetic tape recording enabled master discs to be cut separately in time and space from the actual recording process. Although tape and other technical advances dramatically improved audio quality of commercial recordings in the post-war years, the basic constraints of the electromechanical mastering process remained, and the inherent physical limitations of the main commercial recording media the 78 rpm disc and the later 7-inch 45 rpm single and the January 3 33 rpm LP recorder meant that the audio quality, dynamic range, and running time of master discs was still limited compared to later media such as the compact disc. Running times were constrained by the diameter of the disc and the density with which grooves could be inscribed on the surface without cutting into each other. Dynamic range was also limited by the fact that if the signal level coming from the master tape was too high, the highly sensitive cutting head might jump off the surface of the disc during the cutting process. From the 1950s until the advent of digital recording in the late 1970s, the mastering process typically went through several stages. Once the studio recording on multi-track tape was complete, a final mix was prepared and dubbed down to the master tape, usually either a single-track mono or two-track stereo tape. Prior to the cutting of the master disc, the master tape was often subjected to further electronic treatment by a specialist mastering engineer. After the advent of tape, it was found that especially for pop recordings, master recordings could be made so that the resulting record would sound better. This was done by making fine adjustments to the amplitude of sound at different frequency bands prior to the cutting of the master disc. Record mastering became a highly prized and skilled craft, and it was widely recognized that good mastering could make or break a commercial pop recording. As a result, during the peak years of the pop music boom from the 1950s to the 1980s, the best mastering engineers were in high demand. In large recording companies such as EMI, The mastering process was usually controlled by specialist staff technicians who were conservative in their work practices. These big companies were often reluctant to make changes to their recording and production processes. For example, EMI was very slow in taking up innovations in multi-track recording, and they did not install 8-track recorders in their Abbey Road studios until the late 1960s, more than a decade after the first commercial 8-track recorders were installed by American independent studios. In multi-track recording, each signal input is recorded to its own track on a multi-track recorder. This multi-track tape is mixed down to a mono or stereo tape from which the master tape is copied. A multi-track tape may be remixed many times, in different ways, by different engineers, giving the possibility of several masters. Digital technology. In the 1990s, electromechanical processes were largely superseded by digital technology, with digital recordings stored on hard disk drives or digital tape and transferred to CD. The digital audio workstation became common in many mastering facilities, allowing the offline manipulation of recorded audio via a graphical user interface. Although many digital processing tools are common during mastering, it is also very common to use analog media and processing equipment for the mastering stage. Just as in other areas of audio, the benefits and drawbacks of digital technology compared to analog technology is still a matter of debate. However, in the field of audio mastering, the debate is usually over the use of digital versus analog signal processing rather than the use of digital technology for storage of audio. Although there is no optimum mix level for mastering, the example in the picture to the right only suggests what mix levels are ideal for the studio engineer to render and for the mastering engineer to process. It is important to allow enough headroom for the mastering engineer's work. Bernie Grindman mastering and gateway mastering still embrace the analog signal processing within the mastering process. Mastering has a special significance for house, techno and other styles of electronic dance music. The product of mastering, regardless of the type of format, is reactualized into a performance in the hands of the DJ. In this regard, the shift from vinyl records to digital formats in many DJ scenes and the appearance of new digital formats for DJs have encouraged new practices also among mastering engineers, whose targets are not only music listeners but, specifically, music performers as well. Process. The source material, ideally at the original resolution, is processed using equalization, compression, limiting, noise reduction and other processes. More tasks, such as editing, pre-gapping, leveling, fading in and out, noise reduction and other signal restoration and enhancement processes can be applied as part of the mastering stage. This step prepares the music for either digital or analog, for example vinyl, replication. The source material is put in the proper order, commonly referred to as assembly sequencing. If the material is destined for vinyl release, additional processing, such as dynamic range reduction or frequency-dependent stereo-to-euro mono fold-down and equalization, may be applied to compensate for the limitations of the medium. Finally, for compact disc release, start of track, end of track, and indexes are defined for disc navigation. Subsequently, it is rendered either to a physical medium, such as a CD or DVD-R, or to computer files, such as a disk description protocol file set or an ISO file. The specific medium varies, depending on the intended release format of the final product. For digital audio releases, there is more than one possible master medium, chosen based on replication factory requirements or record label security concerns. Regardless of what delivery method is chosen, the replicator will transfer the audio to a glass master that will generate metal stampers for replication. The process of audio mastering varies depending on the specific needs of the audio to be processed. Mastering engineers need to examine the types of input media, the expectations of the source producer or recipient, the limitations of the end medium and process the subject accordingly. General rules of thumb can rarely be applied. Steps of the process typically include the following: transferring the recorded audio tracks into the digital audio workstation. Sequence the separate songs or tracks as they will appear on the final release. Adjust the length of the silence between songs. Process or sweeten audio to maximize the sound quality for the intended medium. Transfer the audio to the final master format. Examples of possible actions taken during mastering: editing minor flaws. Applying noise reduction to eliminate clicks, dropouts, hum and hiss. Adjusting stereo width. Adding ambience. Equalize audio across tracks for the purpose of optimized frequency distribution. Adjust volume. Dynamic range compression or expansion. Peak limit. Dither. To finish mastering a CD track, markers must be inserted along with international standard recording code along with other information necessary to replicate a CD. Vinyl LP and cassettes have their own pre-duplication requirements for a finished master. See also, Audio Post-Production, DBFS, Loudness War, Mastering Engineer, Noise Print, References.